everyone, welcome to today's lesson. In the previous session, we introduced an overview of mechanical transmission systems. In this lesson, we'll continue with Chapter 6 and focus on the classification of mechanical transmission systems. We will explore various classification methods based on different principles. By the end of this lesson, you should have a clear understanding of the characteristics and application scenarios of each transmission method. First, let's look at the classification overview of mechanical transmission systems. Mechanical transmission systems can be classified according to different principles. There are three main methods of classification. 1. By working principle. 2. By variation of transmission ratio. 3. By variation of output speed. Next, we will explain each classification method in detail. The first classification method is by working principle. According to the working principle, mechanical transmission systems can be divided into three main categories. Friction transmission systems, such as nylon rope, steel wire rope, and belt drives, which transmit motion and power through friction. Meshing transmission systems, such as gear drives, worm gear drives, chain drives, and synchronous toothed belt drives, which transmit power through meshing. Cam and linkage mechanisms, such as screw drive mechanisms, linkage mechanisms, and cam mechanisms, which push the working machine through specific mechanical structures. Please pay attention to the diagram on the screen. Each representative structure of these transmission systems is shown in the figure. On the left side of the image, you can see the friction transmission system, demonstrating the belt drive where friction force plays a key role in power transmission. The middle part illustrates meshing transmission, showing gears in precise engagement, which highlights the features of this type of transmission. The right side presents cam and linkage systems, such as screw mechanisms and linkage mechanisms, which are typical applications in mechanical motion control. Next, let's look at the second classification method, by variation of transmission ratio. According to the variation of the transmission ratio, mechanical transmission systems can be divided into the following categories. 1. Fixed ratio transmission. The input and output speeds are constant. This type is suitable for working machines with fixed operating conditions. Common examples include gear drives, rack and pinion drives, worm gear drives, belt drives, and chain drives. 2. Variable ratio transmission. The transmission ratio can be adjusted as needed. This category can be further divided into step speed change transmission, for example, gearboxes. Stepless speed change transmission, such as mechanical continuously variable transmissions, CVTs, and torque converters. Periodically varying transmission ratio. The ratio changes in a periodic pattern, commonly used in specific motion control applications. The diagram shows examples of different transmission ratio variations. The fixed ratio transmission part illustrates a gear pair with a constant transmission ratio, while the variable ratio transmission section shows a gearbox, emphasizing the ability to switch between multiple gears to change the ratio. Finally, let's look at the third classification method, by variation of output speed. Based on the characteristics of output speed, mechanical transmission systems can be classified into two categories. 1. Transmission systems with constant output speed. The output speed from the prime mover remains constant. Common examples include gear drives, worm gear drives, chain drives, and belt drives. These systems are suitable for applications requiring stable output. 2. Transmission systems with adjustable output speed. The input speed of the prime mover may be constant or adjustable. Examples include step speed adjustment systems such as cone pulley drives and gearboxes, and stepless speed adjustment systems such as mechanical CVTs, torque converters, and electromagnetic slip clutches. In the diagram, we can see an example of a system with constant output speed, a simple gear drive, which maintains a fixed speed output. For systems with adjustable output speed, The diagram illustrates a cone pulley drive, emphasizing that the output speed can be regulated by changing the belt position on the pulleys. We hope that through today's lesson, you now have a clear understanding of the different types of mechanical transmission systems. Thank you for listening, and we will continue with mechanical transmission system design in the next lesson. Thank you, everyone.